So here we are again, back at our little guy. If I were to press some buttons on the side here, obviously I get rid of that little sidebar. This one was called Human IK. Speaking of IK, IK stands for inverse kinematics. So you're probably thinking, what's that? Well, every single mesh you make needs to be controlled by something if you're going to animate it. You're probably wondering what all these numbers are down here, this range slider, etc. I'm going to do a quick little overall overview now of the joint system and how it works. You'll see that on the side here we have the modeling, rigging, animation, effects, rendering, and whatever you want. So we're using the modeling function right now. The next function is rigging. The rigging is used to create the bone structure within the worm in this case so you can animate it. I will stop at rigging, press the button, and you'll see how these change up here. You'll see that it was modeling a minute ago, and now it's, these mesh display, mesh tools, edit mesh. You press rigging, and it becomes skeleton, skin, etc. If I press skeleton, it has joints, insert joints, mirror joints, orientate joints, all these joint things, IK handles, etc. We're not going to deal so much with these things. We want to just focus on creating the joints. This is called an orthographic point of view, if I haven't explained that already. This is perspective view. A perspective view gives you an angle based on a camera angle based on a setting you set yourself. So if you were to go into this view camera, or if I selected the camera itself by going view, select camera, and I did a control A, no, if I do the control, this editor here, it'll give me the perspectives, the perspective camera's qualities. The focal length is 35 right now. 35 is a nice one to be modeling in, but I generally like 55 as a rule. I'm bringing this up now because this is where we start controlling the space here as a theater rather than just a modeling place. So when you're modeling it, you can just use anything you like, but when you're actually orchestrating this as a background in a theater, we have to start viewing this area here as reality, and start wondering how we can make this reality similar to our reality ourselves. And our human eye is about a 50 or 55 focal length, so I'm setting it there just to match our eye. Back to over here, this is orthographic. Orthographic means it has no or infinite focal length. You can see the difference here, hopefully. So if I were to look straight on here, you'll see that, how would I tell the difference? Basically, it allows you to see every point for what it is. So right now, for example, if we're on perspective, you'll see that I might be able to see very little of the outside edge of this because we're in perspective view, but in this case, those points are sticking out more on the side because we're looking at everything as a non-perspective orthographic view. Anyway, I can explain that better probably in person. Here is your worm. We've selected IK, so skin, create a joint. Let's put it on 4 here, so wireframe is on. And I'm going to select the middle of this guy, let's just say it's right here, and we're going to create a bone system like this. I'm going to do the same thing again. I'm going to select the IK, create joints, but I'm going to select this one first, and it will allow me to make a selection from there. So there's our IK system right now, and if you look over the side here, you'll see that it is not center at all. So we need to start moving these to match what the worm is. So I'll move those to match. So there's our worm. Now, if I select these two objects together, and again, we have these selections over here. See skin, and it'll bind the skin. So just those two functions gives you a fair amount of power. What I've done is I've said that all these points here on this object, all these points, these vertex, are now correlated with some joint here. So if I were to move this, it'll move the joint. If I right click on this and say set preferred angle or assume preferred angle, it'll snap it back. Now, you're probably thinking, wow, that's pretty cool. This is how you animate. How do you animate? Well, why don't we just take you right there, so if you really want to play, you could. This is a character in a movie right now, for example. And it's got 1 frame to 121 frames, it looks like. Let's just change this to, right now the range is from 1 to 121. I'm going to say this really quickly and hopefully you'll understand it. In 1 second there are 24 frames. So in this case, if I said 1 to 24, then there's 1 to 24 frames in 1 second. So if I had this whole guy here, and I selected a movement that went from here, this is the root joint I grabbed, from here, and I pressed the S key, S, see how all these turned red, and then I S key here, and then I press the S key again. Let's move this over and press the S key here. So now if I drag it along, that's our animation so far. If I were to move it to the center and lift it up a little bit and press S again, you'll see, then it'll probably go from there, from here, up to here, down to here, right? Up and down. That's the animation, right? Now, same thing goes with this. So if, let's just say, I saved a key with all of these separately, so I'm going to press a shift key, save, grabbing them all individually, and press save. Then I move it to the 12 key, and I now press rotate, and I rotate these all up like that. Press the S key. I'm going to 24, which is 1 second, and then I can go down like that and press save. So this is all going to happen within 1 second. So it'd be like this, would be the speed of this. 1/1000, 2, whoops. So that's how fast this moves. So generally, if you're to do an animation, you probably want to do a lot more than just 24 frames. You probably want to do, 3 seconds, 4 seconds, because that's how long someone would turn and say hi to somebody, and then the camera would pan somewhere else. You can start watching animated movies and see how long cameras stay in one spot. You may find that they move around a fair bit depending on the action scene, or not, depending on on what the director wanted. But in our case, in our purposes, let's just crank it to something like 120 would give you 5 seconds. So why don't we try that? Why don't we put it at 120 total? And that means our guy is going from here to here, and then we could control it by doing whatever we wanted to. We could return him back to the same position by selecting this, and if I right mouse click, I can drag along the slider, put the key here without moving anything at all, press save, and it will return it. So basically what you're going to see is it's going to go from there to there in our 1 second, and then it's going to return all the way back to that other spot with IK. So why is this a problem, or is it a problem? It's a problem for us because this worm is in a pose right now. It's going from here to here and back again, but it's always in this pose. If we wanted it, for example, to come out of a hole, Right? Let's just say we got ourselves a modeling and we got ourselves a little hole. Let's just make a little hole here. Let's just create polygon primitives, a torus. So there's a little hole. Now let's just say we wanted the worm to come out of that hole somehow. Well, let's make it a little bit bigger. So we would go over into here and we would grab this guy and we would move him into position below the hole like this. Save a key, rotate him. See, so how are we going to get this guy to go through this hole like this? And the way it is right now, I could try and rotate these up, save it, you know, like this is going to get very difficult very soon. And then at 12, we need to save all these keys again because they've already been written as a different. So you're saving all these keys, and you see how everything is squishing and it's not looking great. So if even from here to here, I've got this little movement. At 12, I want it to go, let's just say, up a little bit. So it's going to be very tough to get our animated shape, which is like, you know, which was like, I'm going to try and return it, which was this, into a position to go up that hole. It's better if we construct everything in a default position. So if you were to look at a lot of 3D models, you'll see that a lot of people are standing there and they're looking very straight at the camera. They're just looking kind of blindly at it. That's because they are, and if I were to bring up another one, if I were to import, I wonder if I have it on file here. In the library. Yeah, I'll look for it. If I can find Aslan, I'll bring in Aslan. But maybe I can. Nope. What I have here is I have a default person that's got no movement on him. I'm just bringing him in to show you how default he is. Often, if I were to grab this and rotate it up, you'll see that default position is often like this. That's default position. Now allows you to then animate the character any way you want. If you suddenly have a character that was like this and looking all around, and then you had to basically make it act all the time, you would have this shape built into it at all times, and it'd be very difficult for you to animate the character and make it look truly authentic. Anyway, so that's a little bit on IK. There's a lot more to this. I will rig this guy up in the next class so you can get an idea of how things are positioned and why. Because this is a great example to show you how to build something, but it's a horrible example to show you how to animate something.